Hello S1, today we're going to do a very simple demonstration, an experiment which looks at density. If you remember last week we did an experiment where we made a density column. I'll show you a picture of one just up here. And what we did in that was we took liquids of different densities. Some of the liquids were more dense and you'll remember they sank to the bottom, and some were less dense and they floated to the top. So there was a link between density and floating and sinking. Well, today I have a bottle. As you can see, I've actually emptied the orange juice out of this bottle just for this demonstration. I'll have to put it back in later on. And if you look very carefully in this bottle, you'll see at the top of it there is a piece of tin foil. And it's just floating there. So what does that mean about the tinfoil? Yes, it's less dense than the water that it's in. However, watch what happens now. Watch carefully to the tinfoil. Here it goes. And is it going to fall? Is it going to fall? Oh, it falls right to the bottom. There it is. So it sank, which must mean it's more dense than the water. So if we let it go, it floats back up to the top and less dense. So this is known as a Cartesian diver. So to make a Cartesian diver, obviously you need a bottle and a piece of tin foil, and preferably an empty bottle, of course. So what to do is get a glass of water, first of all, not to drink, just to leave it there for the moment, and some tin foil. Now you don't need very much, this is just a bit. I'm actually going to take a bit off this because we don't even need all of that. So just about that amount there, it's about half the size of the glass. And what we're going to do is scrumple it up. Now, if you scrumple it up and make it this size right here, now that's quite big, it would barely fit in my bottle. And I'm just going to plop it into the water, and you will see that it's sitting, now I don't know if I can get a good angle on this, I might have to lift the camera a bit. It's sitting just floating on the top of the water. It's almost like an iceberg floating on the top. And that's not much use. Most of it is still above the water. So let's adjust this a little bit and make it a bit smaller. So now we'll scrumple it up so it's even tighter. And what that means is that we're getting rid of the air in the tinfoil, and that will make it more dense. So let's plop it back in. Oops. And if you look now, you'll notice that it's in the water more deeply than it was before. Okay, and it's still not 100% in, it's not fully in. You can see a little bit over the top of the water. So we're going to try and put it in just a little bit more. So to do that, we'll scrumple it up a little bit more. Now to do this, I might need to push it down the desk. Right, we got there. Now it's really very small compared to what it was at the beginning. So again, we'll plop it in. And this time, if you look carefully, get at the camera, now it's basically just about all immersed in water. It's not fully in. I think I might be able to do that a little bit more. So we'll take it out again and push down really hard. Get all that air out of the tin foil. So we've got a really small ball, and now it's really compressed, and it's just about floating right underneath the surface of the water. Don't know if you can see that there. There we go. Just about floating underneath the surface. And that means it's ready to go in the bottle. So let's find out what happens. So folks, it's the moment of truth. Now we're trying to find out what happens when we put our little iceberg floating in the water here into our bottle. So let's find out. We'll take it out of here, and this is it right here. It's tiny. We're going to put it into the bottle along with the other one, the original one. My fingers crossed it will work. So what we're going to do is just lower them both in. Oh, it's floating. That's good. And squeeze. So let's move the glass out of the way. Tighten the bottle really tight. So here we go. Moment of truth. They're both in there. Let's give it a squeeze and see if it works. Squeeze. Oh no, oh no, oh no. Yay, they both fell to the bottom. Woo, they're both down there. There they are. And we can let it back up again. And where are they? There they're coming up. Are they both up? Oh, there's the second one. It's a lot slower than the first one for some reason. Anyway, That's what I want you to do. I want you to build a Cartesian diver. Build 2 of them if you want. And when you've done it, there's one thing we haven't actually explained, which is why do they fall? So if you can build yours, I want you to build it and then explain to me with a video maybe why whenever they're up at the top are they floating, and why when you squeeze it do they fall down to the bottom. I look forward to seeing your videos. Post them on the classroom and have a lot of fun. Bye!